This is version 2 of the fundamental theorem of calculus, where we're thinking derivative of antiderivative today. But first we're going to just kind of back up and do a regular, simple antiderivative. Took the antiderivative, plugged in the top, now we're plugging in the bottom. Anybody figure out what 5 to the 4th is? I thought I heard you. 625. Plus 25 minus 15. I'll do the easy ones, give you the hard ones. So let's see, that's x to the 4th plus x squared minus 3x. And then, what is this? 650 minus 15 is 635. Okay, so we took an antiderivative. That's not really fundamental theorem of calculus. That's just anti-deriving, underiving, going backwards. Plug in top minus plug in bottom. Now, find the derivative of the above integral. So this looks crazy, but we already figured out what this part is. That is what we just found. So now let's take the derivative of that. So let's take the derivative, not worried about all the junk in there. I'm looking at the hard work we already did, and let's take the derivative of each of those 4 pieces. So, Shelby, what's the derivative of x to the 4th? That would be the antiderivative of x to the 4th. I want the derivative of x to the 4th. So go the other way. It's the easier one. Bring the 4 down.
4x cubed.
4x cubed. Naomi, how about the derivative of x squared? What's that? 2x. Lauren, the derivative of negative 3x? That's just negative 3. And Leah, the derivative of negative 635? 0. Okay, so we sort of walked through what we're about to do by shortcut. We took an antiderivative, and then we took a derivative, and the question is, examine your answer. How does it relate to the integrand? So the answer in the integrand, what would you say about these two things? They're the same. Well, I would think they should be the same, because we took an antiderivative, and then we took a derivative. We took 2 steps forward and 2 steps back, and we got to the same place. But moving forward, we're not going to do that. Like if we go outside again and I tell you to take 2 steps forward and 2 steps back, you're probably not going to move anywhere. You're just going to be like, why are you asking me to do that? Why don't I just stay here and... Okay, but there is something going on. That lower limit, the lower limit of 5 here. What effect did that have on the answer? See if we can kind of trace it through. There's the 5, there's the 5. It becomes all of this, which becomes 635. And what was the derivative of 635? 0. I didn't even write it down. So, answer the question. Does the lower limit of integration have any effect on the answer? No. Because the derivative of a constant equals 0. So probably moving forward, we're not going to worry about it because we know its derivative is 0. Let's see if we can follow the same pattern here to answer this one. Okay, if you tried to take this one step at a time, it would be really hard because you'd have to figure out the antiderivative of something we don't know how to take the antiderivative of. But, gentlemen, please listen. if you hear both instructions at the same time, if you can hear me say, take 2 steps forward and 2 steps back, then realize, wait a minute, that's kind of undoing what we just did. So, do you know how we can answer, or what we do to get the answer to this problem?
Put X instead of
Just put X in for T. It's like, rather than actually taking the steps, why don't I just know that the steps cancel each other out, and I'm right back to where I started, except I've got an X instead of a T. Oh, let's pick on somebody for the next one. Alina, how about the next one? And again, don't get lost in the details. See the big picture first. I'm asking you to take the derivative of an antiderivative.
Use the cosine 5x.
Yep, that's it. And so, there's a long way to go. You can physically walk out the 2 steps forward and then walk 2 steps back, or you can realize, wait a minute, these two things sort of cancel each other out, so why don't I just plug in the top and be done? The trick is, if the top is something a little more complicated, like it's not just an X, I mentioned this already, what do you think the answer is going to be? Like you're going to be pretty close. Okay, so let's plug in the 3x squared. I like that. Plus 1. That's not quite right, because when we take a derivative, sometimes we have to think about the chain rule. So what's the chain rule going to, I don't want to say add on, multiply onto the end of this? Well, I want the chain rule, though. I don't want 3x squared. I want the derivative of 3x squared. So 6x. That's a good answer if you're worried about the top limit minus the bottom limit. So if we're going to plug in 3 for the bottom limit, but we have to do the chain rule for that as well. What's the derivative of 3? 0. So it wipes all that out and we don't have to worry about it. Now, the trick is, if you start wiping it out every time and not worrying about it every time, then when you do have a lower boundary, sometimes people forget about it. So it seems a little excessive to write this out, but at least the first few times I'm going to write it all out just to remind myself that it's still a top limit minus bottom limit. Don't forget the chain rule. And then sometimes we're fortunate enough to where that last piece just goes away. All right, well, what if the lower boundary is not a constant? Well, it's still the same thing. The derivative of the antiderivative cancels each other out. So e to the sine of x squared. But then I need to think about the chain rule. So Julius, if I chain rule sine of x, that would be cosine of x. So there's the top limit. Minus evaluate at the bottom limit, so e to the x squared. But I still need to think about chain rule of the bottom. Ethan, what's the chain rule if I take a derivative of x? Warren, help him out since you've been making the derivative of x is 1. Now, you could clean that up a little bit, but it's also okay to leave it like that because it's also easy to see conceptually what we did. Plug in the top, minus plug in the bottom, and don't forget the chain rule. Okay, this one's going to look real fancy down here because we don't have specific numbers. We just have names of functions. But again, think big picture first. The derivative of the antiderivative, that's going to cancel each other out. So I'm back to f. Plug in the top. That'd be g of x. But chain rule times g prime of x. Minus, plug in the bottom, f of h of x, chain rule, times h prime of x. I mean, yes, it's boxed and starred, but I don't know that I memorized that. Instead, I learned the concept of derivative of antiderivative cancels each other out, plug in top minus plug in bottom. Don't forget the chain rule. Average rate of change is going to wait till Thursday, so we're going to hold off on that. So fast forward to some example problems here. Number one, the derivative of the antiderivative. Again, you think big picture first on these. If you start thinking, forest and trees issue here, if you just look, okay, let me work on the inside. Let me take the antiderivative, which you don't even know how to do, nor do I. Oh, what is that? I don't know if I do or not. But that's not the point. I don't have to take the antiderivative because we're going to do the derivative of the antiderivative. This one would be like if I ask you to walk 5 miles forward and 5 miles backwards. Hopefully you'd be like, wait a minute, I don't think I want to do that. I'm going to end up at the same spot. Same thing. This antiderivative would be ugly, but who cares, because then we take a derivative, plug in the top, don't forget the chain rule. Callie, what's the chain rule off of x? 1. And then, Kinley, do I need to plug in the bottom? And if not, why not? Good. So some of you are going to show the work. You're going to plug in the 3, and then you're going to multiply by the derivative of 3, and then realize, oh yeah, that's 0. I didn't need to do that. Kinley caught it ahead of time, so she didn't really need to do it. It's okay if you do, because it's like conceptually what needs to be done. But if you catch what's going on, then you don't have to write it.
Why didn't we do like the chain rule yesterday when we plugged in?
That's a good question. Why didn't we do the chain rule yesterday? The answer is, yesterday we started with the derivative, and we took an antiderivative. There are no chain rules with antiderivatives. Today we're starting with the antiderivative. We're taking a derivative, which means we need to consider the chain rule. I think that's the best way to say it. Number 2. Let's see. So job 1 would be to plug in natural log of x. So tangent of, this looks a little bit funny, I guess, the tangent of the natural log of x. But then, Macy, what else do I need to tag on to the end of that? Yep. What's the derivative of natural log? Well, we'll let you off the hook because you gave the instructions to the next person. You helped Destiny out by saying we need to take the derivative of natural log. So Destiny, do you know what the derivative of natural log is?
1 over x.
Good. 1 over x. Sophie, how about the bottom one? Do I need to plug that in? And if not, why not?
No.
Why not?
It's just a constant.
Because it's just a constant.
It'll be 0.
And what will be 0?
The plug-in.
Well, I would say no, the plug-in won't be 0. Like, you'll get tangent of 4,
Derivative,
but the derivative of 4 would be 0. So you don't have to put it. Now, I'm going to put it just to contrast with number 1. So you don't have to do this, but if you want to sort of follow the pattern every time, plug in 4, and then the derivative of 4 is 0. So yeah, sure enough, it goes away. Most of you aren't going to show it, but every year there's a few people who show it every time. I guess I just want to consistently do top minus bottom. That's fine. This could be simplified a little bit. I don't know about simplified. Cleaned up, I guess. Tangent of the natural log all over x. And the 0 stuff goes away. What's going to make number 3 a little bit different? What's going to make 3 different? Michael, what makes 3 different than 1 and 2?
Because it's like x cubed.
Okay.
There's an x on the bottom, so there's 2.
Yes, so you will definitely have to plug in the top chain rule minus plug in the bottom chain rule. So why don't you guys try number 3? Plug in the top minus plug in the bottom. Don't forget the chain rule. What makes number 4 a little different than 1, 2, and 3? It's still the derivative of the antiderivative, so I like that. That part sort of cancels each other out.
It's 0 minus.
Good. It's going to be 0 minus, because if I plug in the top, I can plug in -2 if I want to, but the derivative is going to zero that out. So it's going to be 0 minus, and then plug in the bottom one. Cube roots of 1 plus cosine of x squared times, Naomi, I need the derivative of cosine now.
Negative sign of x.
Negative sine of x. Again, safe stop, that's fine, but I've got a minus negative in there, so it might be easier to multiply the negatives and get a positive. I think I would put the sine of x in front of the cube root. I think that would look better, but plug in the top, minus plug in the bottom. Don't forget the chain rule.
Do we do cosine x in the parentheses and then square?
Yes. Yep. Number 5, last example. If g of x equals integral from 1 to x f of t dt, then what is g prime? Okay, well let's ignore the stuff on the right. If I want to get from g to g prime, what do I need to do? Take a derivative. So let's take a derivative of, well, both sides. Of the left side, because that'll get me g prime. And then we'll worry about what happens on the right side in a minute. All right, sweet. Slow it down. Take a derivative of both sides. That way g prime shows up. And now this actually kind of turned into an easy problem, because now I'm trying to take the derivative of the antiderivative of f of t. So what does the right hand side of this equation become? Danny, what's the derivative of the antiderivative from 1 to x of f of t? That's a lot of words. Yeah, what's the right hand side turn into?
0. That right side? Wait, oh, you mean the whole part of this part?
What is this part right here? What does that become?
Just f of x.
Just f of x. That's a whole lot of words to just get f of x. But yes, the derivative of the antiderivative of f is back to f. Plug in x. Chain rule's 1, plug in 1, chain rule 0. But yes, the derivative of g is equal to f. That's a lot of words to land a simple type of answer. Okay, you can see that the rest of the problems start being average value problems. We're going to save that for tomorrow. So today's assignment is worksheet 3, numbers 1 through 6. let me encourage you to try those. I know sometimes you start slacking off and saving things for later, hoping I'll do a bunch of them. Only 6 problems. They're all antiderivative of derivative. Excuse me, the other way, the derivative of the antiderivative. Tuesday, 1 through 6. So try 1 through 6. They should go pretty quick.